Okay, so right now we're going to go over 2.2. Basically, 2.2 is a pretty nice section. It deals a lot with graphs. A lot of the stuff you guys will be very familiar with. In fact, I think almost everything in chapter 2 and 3 you have seen before, but it might be something, maybe one part of this section will be new. So I feel like everything in here you will have seen before. We just need to kind of get the rust off. So it says one of the easiest ways to determine if you are working with a function is by graphing it. So first, and then we're going to work on the library of function and everything like that later on in the sections. But the first thing I want to talk about is the vertical line test. So what the vertical line test allows you to do is it says if you can draw a vertical line anywhere on the graph and you'll only ever touch it one time, then that means that you have a function. But if you can draw it anywhere and touch it more than once, that means that you do not have a function. So this is obviously not a function because, if I draw a vertical line here, I touch it twice, not a function. Okay, so if you can graph something, then you instantly know whether it's a function or not a function. We have this graph right here. If I draw a line here, it's fine. If I draw a vertical line here, if I draw a vertical line here, if I draw a vertical line here. So it doesn't matter where I draw my vertical line, it'll always pass the vertical line test. So yes, yes, a function. Okay, and then over here, I draw a vertical line here, 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 here. Doesn't matter where I draw a vertical line, I will always only touch it once. So it is also a function. So that's why when I told you guys in the previous section, I said, if you know that something's a line, or for example, if you know that something is, let's say, a parabola, okay? I know just by looking at something if it's a parabola, and if it's a parabola, I know it would pass the vertical line test. So yes, that's a function. Yes, this is also a function. So if you can start knowing just by looking at it, whether it is what shape it is, you'll know immediately what you're dealing with is a function. So in this case, it's pretty obvious when something is not a function, like circles, ellipse, hyperbola, those are all non-functional. In general, the conics besides the vertical parabola are all non-functions. And it's not to say they don't exist, they're not good in math, but they're just not, when we're working with functions, we like to stick to functions. We don't want to bring in other stuff. And the majority of this class will focus on functions, okay? And most mathematics you guys take for a very long time will focus on functions. Okay, so the vertical line test is kind of easy to work with. You guys have all seen it before. Now I want to obtain information about a graph. So I'm going to give you, or I'm sorry, I'm going to obtain information about a function f of x. Also, you guys, just to keep in mind, this is a function f of x. Sometimes they refer to it as the function f. So it's kind of like the name of the function. So this, if I had g of x, then the function would be named g, okay? So in this case, our function f, which is based on x or determined by x. So we have part A is the point 3, 6 on the graph. Is it on the graph of 2x over x minus 2? Part B. Well, let's just answer one at a time. So is 3, 6 on the graph? Well, the only way to determine if a value is on the graph of the function, you could obviously graph it, but then you're doing a human drawing and it's harder to see. So what I would do is plug it in. Remember, for the most part, we say that f of x is equal to y. It's just kind of an easier way to write it sometimes. So we'll say y equals 2x over x minus 2. So now we're going to plug in our x is 3 and our y is 6. So 6 equals 2 times 3 all over 3 minus 2. So we have 6 equals 6 over 1, which is 6. So 6 equals 6, so we get an identity. And whenever you get an identity, when you plug a value in, that means it's actually on the graph, right? Or it is a solution to that, meaning that it touches the graph at those locations. So yes, it is. So yes, on graph. Okay, part B. For x equals -2, what is f of x? So this is a fancy way of asking you what is f of -2? That's all they're saying. So then you just take -2 and plug it in. You get 2 over -2, -2 minus 2. So we should get -4 over -4, which is 1. So just so you know, what you actually found is a coordinate on the graph. You found another coordinate, -2, 1 is also on the graph, even though they didn't word it that way. This is, again, something you just want to get comfortable with dealing with the way the book words problems. Let's see here. If f of x equals 3, what is x? Okay, so once again, think about what it's asking. It says if f of x is going to equal 3. So you guys understand that it's saying that the y value is 3. What would x have to be in order for that to occur? So you would take our function, right? 2x over x minus 2. So 2x over x minus 2, and you would set it equal to 3 because they're saying f of x equals 3. We need to know what x value makes that happen. So first thing you guys need to do in general, whenever you have a variable in your denominator that you're trying to solve for, you have to get it out of there. So I'm going to multiply both sides by x minus 2 over 1. So these will cancel and become 1. So now we have 2x, oops, I was using red. So we have 2x equals 3x minus 6. Now let's solve for x, minus 2x plus 6 plus 6. So let's rewrite and see what we got. Let's see here, we have 6 equals, so that's gone and that's gone. 6 equals x. So that means that what is x equal? Well, x would be 6. And once again, they may not have said it, but what you just found is the point 6, 3. Okay, now think about it. Oops, did I write it backwards? No, 6, 3. Okay, so that's that. Now let's look at the domain. So part D, what's the domain? So now think about, what does domain mean? Domain means what are you allowed to use in the problem? What are your inputs that you're able to use? What's the only value in 2x over x minus 2 that we cannot use? Because if we did use it, it would make it undefined. That's right, it's x minus 2. We set it equal to 0, so I would say x minus 2. And I would just solve that real quick. So then my domain is x such that x cannot equal 2. So if it can't equal 2, then it can equal everything else. If we wanted to do interval notation, so this is set builder. And then interval notation would look like this. We would say from -infinity to 2, and then we have to hop over 2, right? Because we're not allowed to touch it. So we're going to use a union to join 2 sets, and then start up again on the other side of 2 to infinity. So this would be interval notation. Okay. And again, these beginning sections don't have too much meat in them. There'll be 1 or 2 sections that I spend a little more time on, but this is kind of a nice section. Okay. And then E says list any intercepts. Okay, so if I'm going to list an intercept, remember to find x-intercepts, let y equal 0, and to find y-intercepts, let x equals 0. So let's do y equals 0 first. So if we go up here, we say 0 is equal to 2x over x minus 2. So we're going to say y equals 0 equals 2x over x minus 2. Okay. So now when a fraction, so when you guys are dealing with fractions, right, you have a numerator and a denominator. Does the numerator or the denominator dictate when the fraction would become 0? It's the numerator, right? Because the denominator determines if it's undefined or not. The numerator is all that matters. So for this, we're just going to say 2x equals 0, so x equals 0. So our x-intercept is 0, 0. So this is my y value, and this is my x value. That's how I got it, okay? So we come over here and it says find the y-intercept. You let x equal 0. So then we have y equals 2 times 0 over 0 minus 2. So this time we let x be 0, right? So then this is just going to become y equals 0 over negative 2, which is just 0. So our y-intercept is actually 0, 0 as well. Okay. Everybody okay with this? Hopefully, if you guys are struggling with how to find x and y intercepts, this makes it a little easier. Whenever you want to find the x-intercept, you just let y equal 0. Whenever you want to find the y-intercept, you just let x be 0. Okay. Let me see if there's anything else I really want to go into in this one. Yeah, I want to do something like this. So we could also take a drawing. And let's say I have this drawing right here. Okay. And let's say that this drawing goes like this. So let's say this is 1, 2, 3, 4, 5, 4, 5, 6, 7, 8, 9, 10. 9, 10, right there. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say this is -1, -2, -3, -4, -5, -6. 1, 2, 3, 4. Ah, geez, I can't get it to work how I want. Oops. 1. Let's do this. So 1, 2, 3, 4. 1, 2, 3, 4. Okay. Oh, geez, I need to go up higher. 5, 6, 7, 8, 9. So 8, 7, 6, 5. And then up here to 9. Okay. So what may happen on an exam question is you may be asked all of these questions. You might be asked to find f of 3. You might be asked to find f of 0. You might be asked to find the point. Let's see here. Geez, I don't know. Let's say 4, comma, I don't know. And then let's do the point 0. Let's do the y coordinate of 0. Let's see what that would be. No, I don't like that one. Let's do it this way. Let's say f of what would equal 0. Okay. So what we could do is we could go down the list and we try to answer these questions. So it's important that you be able to look at that you're able to look at a graph, and then from the graph you plug values in. Okay. So first things first, f of 3. Well, f of 3 means that our x value is 3. Where do we touch the graph when x is 3? We touch the graph at 0, right? Now, what's f of 0 mean? F of 0 means that we take 0 and we plug it into the function. This is some function, f of x, okay? And then based on that, we then can make prediction, or it's not predictions, I'm sorry, we can tell you what our height should be, because if x is your left and right, if x is your value, then y is your height, right? So f of 0 means what height are we at when x is 0? So that's right here, okay? So we're gonna then say that we're at a height of 4, so f of 0, 4. And remember, what we're really doing is we're finding x and y coordinates. Okay, so they want you, when you're doing these in the homework sometimes, they want you to associate what does this guy have to be in order for the x value to be 4. Well, the x value is 4 right here. So I'm right here and I got to look up and I got to look down and I got to find the graph. So the graph is down, right? So I'm going to go down and I'm going to say right about, what does it look like about there? So I'm going to say that this is -3, okay? Now, f of what would give me 0? Well, that means what x value, when I plug it into the function, would spit out a height of 0? Well, that would be here. I have a height of 0 right there for the graph. I have a height of 0 right there for the graph, and I also have a height of 0 right there. So those are all actually the correct answers. So I'm going to say f of -5, f of 3 equals 0, and f of 8 actually also equals 0. Now, a follow-up question might be, what's the domain? And what's the range? Let's use interval notation. So what's the furthest left this graph will go? So we're on the graph, right? We're going this way, we're going this way. How far left will this graph go until it stops? Right to there. So this graph will go up to an x value of -6, and it will go, let's see, let's go the other way. We're going this way, we're going this way, we're going this way. And we hit a x value of 10. And we actually can touch it. Notice that it's colored in dots. So we actually can touch those locations. So we use brackets. Now the range is saying what's the lowest value this graph will ever go to the highest value. So the lowest value to me would be somewhere, the lowest value would be to me right here somewhere, right here. What does that look like? About, I'm going to say -3.5. You could honestly put -4, but it looks like -3.5 approximately. Now, how high will this graph go? Well, the highest point is up here, right? And this graph will go to 9. Now, because this graph didn't have arrows at the end, that's why we ended the domain and the range. But if there were arrows at the end, then the domain would have been -infinity to +infinity, and the range would have been -infinity to +infinity. So just keep that in mind when you're doing these problems. Okay. Let me see if I have anything else from this section. No, that's for the most part, that's a short and sweet section. We can talk about some more stuff in a meeting tomorrow if you guys would like. But yeah, that'll be it for 2.2. Again, not a real tough section, just some background information on functions, how to use the vertical line test, which I think many of you know, how to evaluate functions, and then how to get information about functions from x-intercepts to evaluating. Never forgetting that when you plug a number in, you're finding a point on the graph, you're finding a location. And then this one right here is now interpreting a graph without knowing what it actually is. All right, you guys, that's going to do it for this video. It's going to be probably a little short one for you.